Greetings. This report will be an inquiry into the growing use that data is becoming in the world. Now, when you think of the word data, you probably think of the word computer, or you think of the electronics or computers. And while that wouldn't be wrong, it's not quite what we're going to be getting at, or really what data is at its core, although it is worth keeping in mind that data is utilized on the medium that is computers. But data, at its core, is simply just information. It's the result of a process by which you'd retrieved information and could form a solution. Data, though, in its rawest form, is not usable, though. And so there's some confusions at times with how we phrase it and what we mean. But for the purposes of this report, when we use the words data aggregation, or data accumulation, we're mostly referring to how we get results and outputs in calculations from the inputs that we use. And that'll be an idea that we'll come back to in future slides. But that's the general idea of what data is. And before we go a little bit further, though, I want to address what the process for data accumulation is and what that looks like. Because it's really important to see the theoretical model behind data, to really see that, for one, it's really not based on computers as much as it is abstraction, but also that it's evolving into a way, into a way that is something quite interesting and quite of a cultural shock in a lot of ways. And I think if you can understand just the surface level of what data is and what it's becoming, without really having to get too deep into it, you'll be able to just get a better grasp of how this is changing the world. So we're going to go into that, but before we do, we need to really grasp the theoretical model behind data. And so that's the first question, is what is data? Well, data is, in this model that I've given, it's really a simple model, but I think that it portrays the idea fairly simple. So you've got three, what would you call it? Just things. You could call it really anything. It's arbitrary information right here. We've got an age, an occupation, and a relationship status. Nothing too exemplary, nothing that's really saying a whole bunch, although you could argue that it's saying a little bit. You know, if you knew their age, you could know if they could drive at this age and stuff like that. But it's still very limited calculations. But this is where our process of data is coming into effect, essentially. We take a variable age, we take a variable occupation, and we take another variable relationship status, things that we would consider to be somewhat unrelated for the most part and very one-dimensional, but we can conglomerate these into three categories, and then if we can hopefully find a way to translate that data and its types, then we can come to useful information. As you can see in the slide, that's the end goal. We take age, occupation, and relationship status, and we put them together with the three arrows denoted by the raw data, and then we do the translate process into what is useful information, something that is at the very least correlated and can be used. Now we'll take this model, and I'm also going to note too with this next slide that it's still super worth remembering the fact that data by itself does not mean much of anything. And so this might suggest to you that it's very important to have a lot of data, or a lot of input in this case, because its age is the input somewhat, to really form accurate conclusions. It would be very helpful to have a bunch of it if by itself it's not going to be that important, and you would be right. And you should remember that too for a future slide, because we'll come back to that same idea. But what we're going to have to do to transition into this, is to understand, ultimately though, well, how do we understand data in a more modern example, in a more practical example. But I'm still going to go a little theoretical with this one too. So this next slide, I've used this example where you have sliced bread. It's supposed to be sliced bread. It's like a loaf. You got strawberry jam, and then you've got peanut butter. These three things by themselves, not really that crazy, awesome, just that's what they are. There's bread, there's peanut butter, there's jam. That's it. Take those three things together, what do you have? You have a peanut butter and jelly sandwich, or as you could call it, useful information. Very useful and very tasty information. That's the same exact model that we had just applied right here, and are now applying right here, just in a different form. So you should be able to see that data is not this concrete thing. It's mostly an abstraction. And we'll use this model again right here. We're going to take what we did right here is we have taken this model that we've just taken with the peanut butter and jelly sandwich, and we are now incorporating that model into a persona, into a person. This is a John Doe. It could be anybody. And what we've done essentially is just like we had done with the previous example, we've deduced a bunch of random tidbits of information, or seemingly random tidbits of information, and we've kind of laid them out. And this is the same idea. We'll take all of these bits of information and form a conclusion. Not arbitrarily, but that's the idea. And in this instance, we haven't actually formed a conclusion. I'm just laying them out for you to see the same model being exonerated. And that's the ultimate goal. And in the example, 75% of his time has been spent buying cars and automobile parts, and then 80% of his product types was bought are electronics. And then after that, recently it's cool to note that 42% lately of his items have been infant related, and then that 17% of what you could consider to be music, he has been listening to just podcasts, and he's disabled his subscription services to most music streaming services. So that's something just that I threw in there too. So it's 4 different sort of just dull pieces of information, maybe interesting, just somewhat unrelated, but that's what data is seeking to accomplish, to take these small little random things that we take for granted daily and to really form an accurate solution with it. But we've sort of run into a stumbling block with that. Or we've run into, what would you call it? You would call it a bottleneck with where we're at. But we'll come back to that idea. The next example of this on this slide is this same model now being outputted into the world. So in this case, we're the input, we're the random bits of data. And that's something that I wanted to address because of the ethical overtone of the report. I want to be able to have this part so you can see, well, the same model that we've seen with the peanut butter and the jelly sandwich and then the John Doe is also being applied, and it's being output into these, in this instance, tech companies. Although it could be a number of things because, we're so connected nowadays. But that's exactly what's happening. So the model's very interchangeable, as you can see in this instance. We're the input, and we're going into all of these different subsets. So that's something to keep in mind. And this is the ultimate question within this slide: is how will this data affect our future? Because we are truly at a turning point, that is for sure. We're recently seeing a big adoption of big data or data aggregation in all of mass industries. And you might think right off the bat that that's just kind of a given. Every business wants to market effectively and to find the right people. And I can understand that would be the first thing that you'd think, and that's what I would think. Marketing is certainly up there. But we're going to see in an instance that it's not just marketing. In this slide right here, it's worth noting that although almost all industries are seeking data as a commodity and a resource to keep themselves successful, it's not just for the sake of it being marketing. And in this case, and in this graph that I've provided, you can see a bunch of separate industries that are all encompassing data and data accumulation methods. And so what does that mean? So what would an engineering company need to be marketing for? They're not marketing, that's the thing. They're using these powerful techniques of data and data input to solve real-world problems. And so it's not just marketing examples, it's not just customer demographic examples. And this is an article that was posted in 2017. The graph is very recent with their publications. And ultimately, it's showcasing that this model of data is not just used to figure out what customers are going to buy this at Walmart. It's not just that simple. That's very base level, although it is still kind of tough. We're also using this model to solve problems, to solve why does this happen when this happens at this temperature, at this altitude. And that is how this data accumulation method is evolving across all industries. And why it's going to be very relevant, because as you can see, it's a very high priority list in this graph. It's also a commodity. And now the word commodity, we really don't think much of it anymore, but data is perhaps the newest commodity, the most recent commodity. You could argue maybe Bitcoin, or then you'd be in the definition of what is a commodity, but arguably data is a commodity. It's one that companies use. Its purpose is just information and just knowing things, which is invaluable in many cases, but it's also become an exchange currency. It's something that companies, entities, and corporations, whoever, can use to sell other people's data if the data happens to be other people, which is a lot of times the case. And this is the world we're living in. It's commodity. It's a commodity, and it's relatively new, and it's something that everyone should be aware of, I believe. And now we get into a really interesting portion. So we've come to the conclusions that we take in a bunch of inputs to get outputs, and that's great. We're able to solve a lot of problems that way, and we've been for a while with computers, just taking in an input, getting an output. And like we had said before, though, the problem with this model was that it requires a lot of input to really solve big problems. And the more input you have, the better, but that's a lot of work, and it's tough to find that great input. And so what if it could do it for you? That's where neural networks come into play. And we're not going to get too far into the technicalities of a neural network, or even really how it works. I'm just going to showcase that this overall idea of data and how we can get data is just taking off. It's absolutely taking off. And in this case, quite literally, because neural networks at their core are doing what we had just done in all of these previous slides, but it's doing it automatically. It's doing it automatically by itself. It's learning by itself. And I'm not going to go into the details of how it does that in order to fully understand it. But what you can take from it ultimately is that it takes it at the end result, at the end of all of this, the reason that we create a neural network is so that we don't have to have a bunch of input to figure out a problem. And so what do we do instead? We utilize smaller inputs to figure out an output. And the way that we do that is the neural network within itself is learning at all times through the various nodes that are all interconnected. And then in that way, we're able to not have to have an extraordinary amount of data to figure out solutions to problems. But what would the neural network do for data analytics? Well, glad you asked. An ethics review editorial in 2018 demonstrates that healthcare outcomes were actually able to be predicted through Twitter and Facebook. That's right, social media platforms' data accumulation methods, which is, again, just an algorithm, just a conceptual idea. It's nothing that is this crazy, hard to engineer thing. But that idea in the model is actually been used in the instance here to diagnose and monitor disease activity within a healthcare setting. That to me is interesting, to see that the conceptual idea of just figuring out data is that powerful on just something that we see as sort of arbitrary, like Twitter and social media. It really speaks to the volumes of how powerful this is, and also how portable it is. You could walk around with your phone, and that phone's apparently able to figure out when somebody might have cancer. Now, maybe not right now, but in a few years, it could be a lot more common. And I think that that's 100% to do with neural networks, 100% to do with the compatibility of a neural network to take in smaller inputs and to still be able to give better results. And so, like I said before, this is sort of just a slide explaining that input-output thing, where at the bottom left you see the world's represented by a bunch of binary streams, and that's essentially just saying that the world is full of so much information, too much information. And what happens is, it's too much information, and as you see the equal signs, the computer blows up, symbolizing a system failure. And so that model didn't work for a while, and that's why we're at where we're at. We're working on figuring out more outputs for smaller inputs, and it's doing it by itself. And so this is really interesting. So it means that if we can figure out problems conceptually, we can throw them into a system to figure them. So this would encompass all industries to work together. And that's sort of what's happening. We see in this instance, we have a journal publication for market research, and they actually utilize mostly psychology, and for the most part, they're really unrelated to the computer and the engineering departments. But we all, if we're scientists or engineers, we all sort of think with the same set of tools. And so, but what's been a limiting factor is the inputs. But now, more than ever, we're all able to just give small inputs for problems that we've already understood, and not have to figure out a whole bunch of more inputs and figure out the solutions to these existing problems. And that's what's happening. And we found that they were able to, in this case, actually throw in psychological assessment patterns of people this isn't about the psychology, mind you too. I hope that doesn't just seem distracting. It's more so about the idea of them being able to take these three conceptual abstraction ideas, which were laid out inside of a research study program, and they had all these qualifications for it, and they'd been able to throw that into a neural network system, and it instantly was able to give solutions fast. Whereas before, we would have to go and figure out a whole bunch of things. And really, too, we with the psychological industry, we really couldn't do much of anything to begin with because of the limited inputs. And so, to me, that's just interesting. That's an advancement that only neural networks could have provided, and it's bringing together cross industries like never before. What else is this data analytics going to provide? Remember, data analytics being just what does the data mean and what can we do with it? Well, let's do a little summary real quick. Well, so far it can store people into categories, it can figure things out about people, or just anything, not people. It can figure things out. And then it can also form predictions, as we've seen with the neural networks, about what might happen in the future. And now we're coming to sort of an ambiguous purpose or function of big data, but we're still seeing it nonetheless, and that is a monitoring type system, or a monitoring type ecosystem that seeks to sustain itself. Sounds a lot like AI, pretty much is. But we see in this example a bunch of elements that go into the healthcare industry, and they all should seem pretty familiar, if you live within a first world country. Regardless if you think about who's my private insurance and who's my pharmacy on like a really deep level, I can promise you corporations and businesses do. It's valuable information to them, and they can and are and have and will continue to find solutions with this information. But not only that, we've known that for a while, and you can see this picture, it's nothing really that revolutionary, but what this is really starting to do is to become an alive, encapsulating ecosystem where it will track and monitor if stuff is changing in a way that has happened before in previous circumstances. If someone's medication slips to this, say it's a dosage of that, and then they go to the doctor for this diagnosis, and then the system picks up on that, and it knows that this happened at one point and this person died. That's sort of the idea. Very, very brief, broad example, but a monitoring type ecosystem, and that is certainly only capable from neural networks because of its autonomous nature by default. So that's already sort of in the works. So we come to the ethical questions, and this is almost the end, and we're wrapping up, but it's certainly fair to raise the ethical questions. Is society becoming too observable in a scientific lens? And I've included the 1984 illustration here just to kind of give that idea. Ultimately, it's too hard to say. The future is always unknown, obviously, but we do know that technology seems to continue to evolve. All we can do is make accurate predictions as best as we can, but one thing remains certain, and that is that data is not going anywhere anytime soon, but that it's also something that anybody can use and harness its power if they know how to. And so I think that's something that's very empowering, and it's going to be very applicable for the future. And I would like to thank you for listening to this presentation, and wish you a great day.